Yeah, we did. Working constraints, finding maximal minimums off the shaded regions. I'm hoping that by the end of over the weekend or late last night or first thing this morning when you finally got around to finishing up the homework, you probably noticed it wasn't terrible. Okay? All right. So here's what we do. Are there any, you guys okay with those? I mean, I know first hour they had one question with, I want to say it was 20. What's weird about that is that you do get fractional intercepts, and that's okay. It's perfectly fine. It just, I think you wind up with like 4/3 for one order pair, like 13 thirds or something like that. You wind up with some weird intersected points because of the 13. That's what makes that one a little bit odd. If you look at how it sets up, obviously this is our first quadrant problem. And what's nice about this then, if you've got first quadrant, the next one is negative x plus y is greater than or equal to 0. That's basically the same thing as saying y equals x. Okay? Which means I get a line with a slope of 1. Okay? What's that? Pick a point down on that line. If I say that that is at 10 and 0, I can test it back here. Is negative 10 plus 0 bigger than 0? No. So I know it's false below, which means it's true above. Okay? So it's in that region to start. So you can kind of see it better there. Okay? Go to the next one. You have x-intercept 2, y-intercept at 4. Inward or outward if you're shaded? Outward, very good. 0 plus 0 is not bigger than 4, so it's out here, which gives you a point here. Now, that's the intersection of these two lines, y equals x and 2x plus y is 4. This is a prime candidate for using substitution. If I do that, I can say that 2x plus x is 4, because I have y equals x here. So I get x is 4/3. So if x is 4/3, y has to be 4/3. It's really nice how that works out. And at this point, most people are like, I don't know what I'm doing. I got something wrong. I got a fraction. It's okay. You're going to get fractions. It's not a big deal. What's nice is at least the ordered pair is clean. They're both the same. You go to the next one. You have a y-intercept at 13, an x-intercept at 6.5. 13 over 2. We draw that one in. And that one is moving inward because 0 plus 0 is smaller than 13. Then we just got to figure out that stuff. Again, super easy because you've got y equals x. So you get 3x is 13. So that's where you get that 13 thirds. Does that make sense? It just looked weird, and people have asked questions about that one pretty regularly because they're not used to seeing the fractions. Okay? That's fine. They're not. When you get fractional ones like that, they're not going to be awful because you get a lot of them where you get y equals x, x equals y, things like that. Okay? Ready for the fun stuff then? Yes, sir. Sure. Yeah, okay. What happens here, what most people forget on this one, it's a first quadrant problem, but it's got 2 verticals and 2 horizontals. You have 0, 60, 45 here, like that, which gives you this intersection at 60 and 45. The other one you get 84, is that right? Yeah, 84. it's 70. You get these intersections, and what's nice about that, this is the x value, since it's vertical, that'll be the x value there. This is the y value, so this will be the y value for that one. So you're just putting in the value of x, get the y, and then do the other one. So you get it like that. Does that help? That's how that would work. It's just weird. We hadn't had one where it was written like that. All right. Let's talk about word problems. And what I want to look at today is I was able to get through a good solid 3 of these without too much of the hassle with first hour. It should be the same thing with you guys. It'll be very helpful if we stay on the phone while we do that. I know this is not a way to see you. I don't know why you're trying to avoid it. Don't look at me! Don't look at me! Don't look at me! Oh, what I do? Look at you! You know, because you're sitting there like this with your head down. So he's not going to see me if I don't see him. Nobody can pay it. Devin, don't worry about it. We're okay. Want to show Devin what happened? You sure? Devin, do you want to see? All right. Come here. Oh, this embarrassing. I don't know if you can see very well. Oh, Devin, we lost you. Did we lose you? I didn't unplug you. Oh no, we unplugged Devin. Devin, come back. Come back. Come back, Devin. Whew. All right. Oh no. We've unplugged you. Are you back? Can you hear me? Are we okay? Can you hear me? Say yes. All right. So I don't know if you can't see her. Stand up real quick. Show Devin. Don't worry about it. I guess she's embarrassed because she's just embarrassed. All right. Can you hear me okay though, Devin? I can't see. Yes or no? Oh, my sound's not on. That's why. Can you hear me now? All right. So we took out the one sheet that had the 2 questions. You got that one? Nice. All right. Linear programming. Linear programming is going to be the first step on a lot of the stuff that we do in honors that other classes don't. Well, this is one of the first things we talk about. It's kind of a straightforward way of utilizing word problems, utilizing linear equations, intersection of equations. Put away your phone. I've asked you twice now. Intersection, shading, all of that. How we solve systems and how we write up what's going to be our own personal constraints. Well, as you go through these types of problems, a lot of times what we're looking for here is that you have to read carefully to what it's asking you to do. For example, if we start this one out, excuse me, your club is selling plans to raise money by selling 2 sizes of fruit baskets. The plan is to sell buy small baskets for 10, sell them for 16, buy large baskets for 15, and sell them for 25. Club president estimates you're not going to sell any more than 100 of them. Your club can afford to spend up to $1,200 on the baskets. Find the number of the small and large fruit baskets you should buy in order to maximize profit. What is the objective of this problem? Yes, sir.
Try to get X and Y to equal.
Not exactly. What's your main goal here? What's the goal? Make money. Make the most money. Maximize your profit. So what it's doing here is, remember how we talked about that objective function last week, where we said that was that C value, C equals something, something? This is where that comes from. First thing we do is we're going to look for what's called the objective function. Each problem is going to be a little bit different. Some of them might say your objective is to maximize profit. Some of them might be to maximize seats. Some of them might be to minimize time. Could be anything, okay? In this case, it says profit. How do you determine what profit is when you're buying and selling stuff? How do you figure out your profit? Yes, ma'am.
The difference between how much you buy it, how much you buy it for, and how much you sell it
Perfect. It's the difference between how much you buy it for and how much you sell it for. Well, you're selling two things, small fruit baskets, large fruit baskets. So how much profit do you make on a small one, and how much do you make on a large one? Yes, sir.
$6 for a small one, and $10 for a large one.
Perfect. Everybody see that? You're buying them for, you're buying them for 10, selling them for 16, which means you make $6 profit. Sometimes they will tell you your specific profit, sometimes you have to figure it out. Bonjour.
Hey. All right.
Hey. Psst. This is the second floor? Oh, these are stairs. All right. So we make whatever. $6 here and $10 for the large. One of the things you'll have to be careful with a lot of times with these problems is how you label them, because it's really not always X's and Y's. I usually keep them with what you're selling, what you're working with. We have an example here coming up about different types of seats on an airplane, business class, tourist class, things like that. So we use different letters. So we have, excuse me, our objective is to maximize profit. We make $6 per small basket, $10 for large. Now, when we've done these problems, these were usually X's and Y's. Do you guys agree? And also when we did these problems, we always want to graphing something. So if you keep in mind that if your first set of values, you're playing the role of X, the second set is playing the role of Y, remember that when we go to graph, put the small baskets here, the large baskets there. Does that make sense? Because it's very easy just to accidentally flip-flop, and you might reverse your ordered pairs. Okay? And that's a common thing. Okay, it's a very common thing. But however you write it out, whichever one you put first, treat it as your X coordinate. Okay? If you remember that, it's really, really easy. Rest of this problem has some other information. It talks about how much money you can spend and how many baskets you can probably sell. Does it say anywhere in this problem that you're going to sell 4 small baskets for every large or 2 large for every small or anything like that? It just says you're going to sell small and large. How many of them at most are you going to sell? 100 of them. So it means your total sales figure is going to be small plus large has to be less than or equal to 100 because of the word selling no more than 100 of those baskets. Does that make sense? Sometimes it might say you expect to sell 2 large baskets for every small, which means it would have been 1 small plus 2 large plus 100. It's pretty straightforward when it comes to that. And then lastly, it talks about cost. How much money can you spend? Can I spend more than that? Can I spend $1,200? Yes. Can I spend less than that? Yeah. So I'm going to spend up to and including $1,200. How much money do I spend per small basket? 10. How much per large? 15. So I have $10 per small plus 15 per large. What's happening here is that I'm using information that's put into the problem, talking about how many you're going to sell up to, how much money that you have, and I'm piecing out what information in that word problem to get me there. All right? Can I sell negative fruit baskets? That means this is a first quadrant problem. I can't make negative right. So this has to be greater than or equal to 0. And that's how we set this up. Okay? By taking that and reading into it carefully, it's very easy to pull apart what you're looking for. Now we plot it and graph it just like we did for the past few days. All right, knowing that we're in first quadrant. So here we have intercepts to start with. I have intercepts at 100 for both of these. Are we okay with that? Pick a spot, call it 100. Here's 100, 0. Here's 0 and 100. Does that shade outward or inward? it shades inward because 0 plus 0 is smaller than 100. Okay. Do you see why I use arrows and not that overshading now? This is the main reason why we do that, just with direct arrows, because we're able to see better where things intersect. Okay? We go to the next one. I have intercepts, if I cover and solve doing my quick graphs, I have an intercept of the small basket at, what, 120? The large basket is going to be, is it 80, I think? I don't remember. Is it 80? So I have 120 and 80. Does that move outward or inward? It moves inward again. Which means I have to figure out that spot right there. I have to find the intersection between these two, which in essence works out to be another system of equations. When you have single variable stuff, a lot of times it's really, really easy to set it up using substitution. I always thought it was. I mean, you don't have to. You can do a linear combination, multiply the top one by 10, subtract the bottom. It works the same way. I always think whenever I see variables with coefficients of 1s, just to set them, use substitution. Here's what I mean. I can say that the small basket is 100 minus the large basket. We okay with that? So now what I'm going to do is I'm going to say that 10 times 100 minus the large basket plus 15 large is 1,200. You okay with that? Substitution. We're solving where those points intersect. All right. 1,000 minus 10 plus 15 is 1,200. I get a large basket equal to 40, which makes my small basket 60. Very good. Okay. That gives me an ordered pair here, and this is why I said it's really important to make sure you remember which side is which for in terms of your axes are concerned. Since I know that my large is playing the role of the y value here, my other one, if I substitute in, gives me 60. That creates 4 points I have to check in my objective function. 6 small plus 10 large. 0, 80, 60, 40, 100, 0, and 0, 0. Hey, I'm going to cut your workload down by 25%. Which one of those don't you have to worry about? And why don't you have to worry about 0, 0? Because you want to make some money here. Doing absolutely nothing and selling absolutely nothing isn't going to help you accomplish that goal. So you don't have to worry about it. So now knowing that you've got your sets of ordered pairs, your excuse me, small, large, it's direct substitution, just like we did the past couple of days. Okay? This is why we are slowly building into this to be able to just basically do the same thing over and over again, but you just have to come up with the parts of it yourself. Right. So let's see, we get 0 plus 800, 360 plus 400, and then 600. So this is, what, 760? So actually, I get a maximum at just selling 80 large baskets.
Oh, okay, that's okay.
All right. I'll make the most profit if I only sell 80 large baskets. Okay. Not too terrible. It just looks weird to start with. All right.
Yeah.
Yeah, right? Sorry. Yeah, I'm wearing my pajamas. I don't have my wallet on me. So. I don't have pajama pants. It's hard to find pajama pants that are long enough, tall. Everyone I've ever had were just, they stop at like halfway up my calf.
That's why I have my mom's on.
I have the same problem.
Yeah.
I wear it for like a year.
Yeah.
So,
So you're.
Let's go to the next one. The next one. Because you have so much time upon your hands, you've decided to stencil wooden boxes for money. Dirks, you never know. It might happen. You might find something that you get good at and you want to make money off of it. You never know. You never know, okay? It could be the next craze on Pinterest that people want to look at a lot. Anyway, so you have decided that you're going to stencil wooden boxes and sell it at a fair. It takes you 2 hours to stencil a small box and 3 hours to stencil a large box. You make a profit of $10 on the small, 20 on the large.
$10.
Okay, I get it. They're getting paid $5 an hour. This book was written in 1991. All right, whatever.
less inflation and like
Yeah, right. Yeah. I think back in it was about. I don't know. I don't remember how much it was. Anyway, if you have no more than 30 hours to stencil and you want to sell at least 12 boxes, how many of each size should you sell to maximize your profit? Again, in this case, what is your objective?
money.
Money, 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 money. Maximize profit. Okay, so we start right away. All these problems, you always want to figure out what your objective is. If you understand what the objective is, that's taking out most of the information. You know you have to maximize your profit, so we start by, well, what's your profit? 10 for a small, 20 for a large. Hey, guess what letters I'm going to use again? 10 small, 20 large. What do you think? How do you think I'm going to graph it again? S on the x-axis, L on the vertical. Just because that's the way I wrote it out. If I wrote it out 20L plus 10S, I would flip it. That's fine. Okay. But I'm just going to make a little mental note that I know that when I go to graph this, I'm going to put S on the x-axis, L on the vertical. Okay. Now, going back into the problem, it talks about what other two things? Time and how many you can make, right? Or sell, excuse me. How much time do you have to use? Can you use more than 30 hours? Can you use less than 30 hours? Can you use 30 hours?
Yes.
So you know that no matter what, you're going to get to the point of less than or equal 30 hours. Now, according to the problem, it tells you how much time per type of box. 2 for small. Very good. All right. Next thing it talks about is sales figures, like how many you want to sell. Does it say that you're going to sell 3 small ones per every large? It just says you're going to sell small and large, right?
Yeah.
But it also says you want to sell at least 12. So is the at least 12 going to be the floor or the ceiling? It's the floor. So that means you want to sell more than 12. But you can't sell 12. Now, what are you going to do to figure out how much you're going to how much you're going to sell? Excuse me. Yeah, exactly. Okay. And lastly, are we going to have negative boxes? No. Do I need to write down that constraint? I don't have to. Okay. It's not a big. If you want to, by all means. But you already know that you're not. You can't have. It has to be a first quadrant problem because you can't have negative sales stuff. Which of those are? Well, start with our quick graphs. On their first equation, what's your S-intercept and what's your L-intercept? 15 and 10. Very good. I know. One of the things that I tell students on this is you start to learn placement scale, if that makes sense. Notice how I put 15 out about that far, but 10 is a little bit closer. It's not close. I mean, I'm not like counting anything. I'm just kind of guesstimating, knowing that 15 has to be further away than 10, because it will be easier to figure out some intercepts at some point if it looks somewhat close-ish. Connect them. Does the arrows go inward or outward? It's moving inward again. Good. Okay. What are the intercepts for the next one? 12. So they're both 12s. Very good. They're both going to be at 12. And this is also why I do that, because that way I can place 12 prior to the 15. I can put 12 after the 10. Hey, looky, looky. They ran into each other, didn't they?
How did that happen?
Oh, inward or outward on that one? Outward. It's outward. It's awkward. So notice we have this little wedge now here. Little triangle right there. I need to figure out that intersection where those two lines. Hey, isn't it going to be really easy to say that S equals 12 minus L? Just by using substitute, or by maneuvering it over?
Yes.
You can use a linear combination of that as well. For some reason, my brain, whenever I see just the same variables, or sorry, the same coefficients like that with ones, I always just move it over. I always thought it was quick. Okay? So I'm going to solve that system like that. So I know that's 2 times the 12 minus L plus the 3L is 30. Which means S is 6. Okay. So we have an ordered pair here at 6 and 6. Oops. Me not being able to write sideways. Okay. How many ordered pairs do we have to check now? We'll have to check the 3. That shaded region created that little triangle space. I only have to check those 3 spots. I got to check it in my cost function by profit at 6, 6. 12, 0, and 15, 0. So we had 10 S plus 20 L. 10 times 6 plus 20 times 6. 10 times 12 plus 0. And 10 times 15 plus 0. Well, this is 60 and 120, 180. Yeah. So I need to make and sell 6 of each. Okay. Linear combinations, believe it or not, are what you would use for just about any type of economic situation. For the most part, if you're going to try and buy or sell something, most economic style problems that you come up with, whether if you're going to build things to resell them, you want to know how much money you have to start with, how much money you want to build out to, how much time you have to afford to be able to do that. This is how this stuff works. They do get more complicated. Don't worry. That's tomorrow. But for today, we start out really, really slow. Okay. Do we have questions on those yet? Yeah. Hmm? Yeah. Yes, because we have this. Let me go back to this other page here. We're looking for the shaded region of the overlap, and it wound up being just in that little small wedge. Usually, what I've done is, since I knew I had, blame Devin. Since I knew I had Devin right there on the corner, I usually put this in a separate screen or put it on the whiteboard, but I wanted to keep it all in the same spot.
Yes.
All right, let me show you another one here. All right, so I'm going to the other one with the 5. We're gonna try and do that first one real quick before you get out of here.
I doubt we can get it at a time.
For him? We'll try.
Actually, no, it's 30 seconds.
Okay. So this next one, what we're looking at is we're gonna talk about airline, like seats and things. I probably need to read off what airline. You know, I said like 15 on the back. I've used this worksheet many years, but I don't have them all memorized. Oh, I'm going to throw it at me. I'm like, really? Hold on. What's up? Oh, sorry. I gave you the... There you go. Sorry about that. I didn't realize it was these were some of the other ones I did use. I didn't realize in the pile. All right, so let's read this first one. This first one has us talking about fly high airlines. So fly high airlines, they sell business class and tourist class seats on charter flights. To charter a plane, you must sell at least 5 business and at least 9 tourist tickets. The plane can't hold more than 30 people. They make a profit of $40 on the business class and $45 on the tourist class. In order for the airlines to maximize profits, how many tourist class should they sell? So you're still going to be figuring everything else out, but in the end, instead of figuring out the actual profit that you would make, what is the value of the tourist seats? How many of those seats? So you're looking at the ordered pair for one specific part. We set it up the exact same way. What's your objective? Make the most money. Our objective is to maximize profit. Okay? What was it? 40 for business and 45 for tourists. So I'm using B and T, which means where do you think I'm going to put my B values? On the X, and my T values will be on the Y's. Okay? All right, now we go. Yes, sir. Yes, sir. Next part, it talks about you need to charter. In order to charter the plane, you have to sell more than 5 business. So what's the bottom? Yes, sir. Oh, I'm sorry. It says at least 5. So what's the minimum amount of seats you can sell for business? 5. So the business, you have to sell more than 5. Tourists, you have to sell more than 9, I believe it said. You okay with that? It's still a first quadrant style problem, but what happened here is instead of selling no business class seats and all tourists, they're saying that there's a lower level that you can have. You have to have at least this many of these people on the plane in order for it to take off. All right. Speaking of planes, how many seats are on there? You have less than 30. And you have more than 30. Nope. You could try. Planes do that anyway. Right? So business plus tourist less than or equal to 30. The last bit on here, we know it's got to be all greater than 0, correct? Do I need to write it?
Yes.
We can. We know that B has to be greater than or equal to 0. T has to be greater than or equal to 0 as well. Sometimes what you're going to see is that they will write it like this. That's bad. Sorry, it won't go like that. It's got to be bigger than 0, but bigger than 5. All right. So place where 5 is. I'll put 5 here. Oh, we left. Oh, I didn't buy one. Bye, Devin.
Just kind of left it that same.
Yeah, well, I didn't have the, apparently the volume was off, so, oh, thank you. So we've got the 5, and that's going to be going this way. and it's got to go to the right. Everybody okay with that? Okay. And now tourist class has the we'll put the 9 in. And what direction does that has to go? Up as well. That has to move up. This point is where they intersect. What's that ordered pair? 5, 9. Very good. That'll be at 5, 9. So as of right now, we have the shaded region. It's still first quadrant problem, but it's just been shifted over some horizontal and some vertical. Sorry, I had to. That was bad. But now I have to do intercepts. Now last one I have to do intercepts where? I've intercepts at 30s for the other one. So I just place my 30s out. 30, 0, oops. And 0, 30. Oops. Is that one moving outward or inward? Moving inward, isn't it?
Yeah.
Okay. It's moving inward. So we get this region in there. You okay with that? Now, if you do that, you also now know ordered pairs on the sides of that triangle, don't you? You know what your vertical is, and you know what your horizontal is. What's the vertical? 5, which makes your horizontal 9.
What letter does that have? That is also
And what you're doing is you're just substituting in these values into there. So if my value of B, that vertical part, is 5, how many tourist class do you have then? 25. If I have 9 tourists, how many business class do I have? 21. At this point, do you even need to answer the question about to figure out profits? No, because it asks you, in order to maximize profits, how many tourist class seats would you have to sell? Well, tourist class was which one? The B or the T? So which one does it have to be? Yes, sir.
25.
It has to be 25. Not only that, because if you look at it, there's 25, 21, the 9's not even in there. So you're done. You got it right away by looking at it. You didn't have to finish that last step to actually figure out the numerical value of the profit. All right. Yes, ma'am.
I'm kind of confused because they wait. That works on my
Good question.
I got the course business confused. I'm like, that business have 9, and I'm like, how can they have 9 if we only have 30 customers in the course? And then I realized.
You look worried. What's wrong? You had that look of. I'm sorry. Didn't mean to put you on the spot. All right, real fast since we have a minute. Look at the next question. Oh, yeah. Oh, you got like 9. You guys are going to do problems 2, 3, and 4 tonight, okay? It was just 25. Yeah, because when you look at your ordered pairs, if you go back and you look at what we want with ordered pairs, it's nice when you have multiple choice like that. Which of those is the tourist class? 9, 9, or 25? Which one's the biggest number? Okay. You still got to figure out the intersection values, but it's really easy.
Yeah.
Now, ladies and gentlemen, if I look at number 2, talks about the dance theater. According to school policy, no more than 2,000 general admission and no more than 4,000 student tickets can be sold. It costs 50 cents a ticket to advertise the dance company to students and $1 to advertise to the general public. Dance company has an advertising budget of $3,000 for the show. Find the maximum profit the company can make if it charges $4 for a student and $7 for general admission. How many student tickets could they sell? Now, what's the objective? Make money again, okay? So if I'm going through this one, I know that my objective is that I got $4 per student, $7 for general. I'm going to use S and G. Okay, that's for student general. So where am I going to put my S? On the X? Yeah, the X. Geo and vertical. Okay, just to get ahead of ourselves. It talks about maximum number of seats. How many students? What's the general admission, the maximum general admission? 2,000. So the general admission has to be less than or equal to 2,000. Students have to be less than or equal to 4,000. You okay with that? Yeah. Does it say how many seats you have to sell total? You know how the other ones said that we had to sell up to 30, couldn't only have 30 people on a plane? The other one, or another one had so many hours you could work, things like that. But this one, it talks about advertising budget, doesn't it? How much money do you have to spend? 3,000. Okay. Can you spend more than 3,000? No. So you can spend up to $3,000. How much money do you spend per student ticket? 50 cents. So I'm sorry about the 0.5s. Sorry.
The tiny S.
I'm trying to differentiate between this 5. I'm sorry. And then, what was it 1?
You can change the S to a
Yeah, right. Can you have negative students or well, you have negative students. Many of you guys are negative people. Anyway, can you have the negative number of tickets? So it has to be a what kind of problem? That's how you start these out, guys. By picking out small bits of information. Actually not as scary as what it looks like, is it? So I've kind of started that. So you basically have 2.5 problems to do for tonight. We'll do about another 4 of them tomorrow, and then see how we're sitting out. Okay? Good times.